In this video, you will learn about the different types of solutions to equations as well as how to solve a literal equation. All of the equations we have solved so far have had one solution. However, this is not the case. You may either have an equation with one solution like we discussed before, an equation with no solution, which results in a false statement such as 6 equals 3, or infinitely many solutions or all real numbers, which indicates that the equation is always true and results in a true statement like 5 is equal to 5. In this example, we are going to begin like we are solving any other equation. So the first thing we need to do is combine our like terms to simplify both sides of the equation. So on the left side of the equation, 11 and negative 7 are like terms and can be combined. So our equation would become 3x, and then 11 minus 7 will give us plus 4. On the right-hand side of the equation, we have 6x and negative 3x are like terms. So we can combine our like terms, so 6x minus 3x becomes 3x, and then we continue to add that plus 5. The next thing we need to do is bring all of the variables to one side of the equation. So I'm going to move this 3x from the right side over to the left side. In order to do this, I'm going to subtract 3x from both sides. So on the left side, 3x minus 3x gives us 0, so there's nothing there. Plus 4 is equal to, and again, 3x minus 3x is 0, plus 5. However, 4 does not equal 5. Since this is false, this indicates that there is no solution. In the next example, we're going to begin with the same process. So first we need to simplify both sides of the equation by combining like terms. So we're going to combine 6x and negative 2x on the left side of the equation. So 6x minus 2x gives us 4x and plus 5. And then on the right-hand side of the equation, we can combine the 4 and the 1, so it would simplify to become 4x plus 5. Now the next thing we need to do is bring all the variables to one side of the equation. So I'm going to move my 4x from the right side over to the left side. In order to do so, I'm going to subtract 4x from both sides. So that will give me 4x minus 4x is 0, 5 carries down, 4x minus 4x is 0 again, and that 5 carries down. Since this is a true statement, we can either say that the solution would be all real numbers, indicating that any number could be substituted and it would work, or the other way we say this is infinitely many solutions. In this next example, it asks, is the equation sometimes, always, or never true? So that's trying to get us to determine if there's one solution, no solution, or infinitely many solutions. Now to do this, we first just need to solve the equation. So the first thing we need to do is check to see that both sides are simplified, which they already are. The next thing we need to do is bring all the variables to one side of the equation. So I'm going to bring my b from the right side over to the left side. So I'll subtract b from both sides, which will give you that b minus b is 0, so there's nothing left. 3 carries down, 7 carries down, and b minus b is 0. Now since 3 does not equal 7, that indicates that it's false or no solution. Since it is false or no solution, we could then say that the equation is never true. or there's no number that we could substitute for the variable to make it a true statement. In this next example, we need to simplify both sides of the equation. Now the left side is already simplified, so we can rewrite it as 35 minus x equals, on the right side we have to first distribute that negative 7 to both terms, so it's minus 7x plus 35 plus 6x. Now again, the left side is already simplified, so we're just going to rewrite it. So it's 35 minus x, and on the right side we have to combine our like terms. So we can combine the minus 7x and the plus 6x. So negative 7x plus 6x becomes negative x plus 35. Now I need to bring all the x terms to one side of the equation. So I'm going to move this negative x to the right side by adding x, or 1x, to both sides. So that'll become 35, and then negative x plus x becomes 0, and negative x plus x is 0, and the 35 carries down. Now since 35 is true, we could say it was all real numbers or infinitely many solutions. And again, this is going to indicate to us that the equation is always true. So no matter what number I substitute in for x, it will always result in a true statement.